Find the horizontal asymptotes for the function f of x equals 5 over x. If you know about vertical asymptotes, you can recognize right away that when x equals 0, this thing will have asymptotic behavior. So let's see, just using that and a table of values, how much we can learn about the behavior of this thing. We'll feel our way through this, and then when we're done, we'll see if we can come up with some general rules that'll help us later. Let's say if x is, let's do minus 5, minus 3, minus 1, 0, 1, 3, 5. I'm just taking some negative numbers and some positive numbers, and we'll do 0 because we know something interesting happens there. If x is negative 5, then f of x is 5 divided by negative 5. If x is negative 3, we get negative 1.67. If x is negative 1, we get negative 5. If x is 0, this thing's undefined. We knew that vertical asymptote there. And then we get 5, 167, and 1. So let's see how much of a graph we can create with that. Okay, negative 1, 2, 3, 4, 5, 1. There's one of our points. Negative 3, we have, that's negative 1, that's negative 2, so 167 is about there. If x is negative 1, we have 1, 2, 3, 4, 5. We know there's a vertical asymptote right at 0. I'll actually mark that in. And this does appear like it's behaving the way we'd expect around a vertical asymptote. It's going down more and more sharply. It will get close to that asymptote but never touch it. And something similar happens on the other side. We get 1 and 1, 2, 3, 4, 5. And we get 3 and 167, something like that. And then we get 5 and 1. That kind of curve. Now, for horizontal asymptotes, we're wondering, what does this thing do out there off to the right? Does it ever start to curve upwards? Does it flatten out? We can tell from taking a derivative that it's never going to change direction, but will it cross the x-axis or anything like that? What happens if x is bigger than 5? If x is 10, for instance, we get 5 divided by 10 is 0.5. I'm not going to have space to plot that, but let's see what happens if we go, let's go way bigger. If x is 100, we get 0.05. If x is 1,000, we get 0.005. The idea is that even if x gets extremely big, a million or a trillion, this thing is never going to go to 0. It's just going to become extremely small, and we get behavior that we call horizontal asymptotic behavior. This line will get closer and closer to 0 without ever quite getting there. And the same thing happens on the left side. If we went negative 10, negative 100, negative 1,000, we would again get y values that were negative but extremely small. And so we say that in addition to having a vertical asymptote here, this function also has a horizontal asymptote right at 0. This, y equals 0, is another line that the function will approach but never actually reach. And in general, that will happen anytime you have a number divided by a power of x. This number will stay put. This power of x will get infinitely big as x goes larger and larger. And so we say the limit of this function will approach 0. And in general, you can say the limit as x goes to infinity, meaning as x gets infinitely big, of any number divided by a power of x will be 0. It doesn't matter if this number a is extremely large. If you divide it by bigger and bigger powers of x, they will eventually cut it down, and you'll end up with a number that's approximately 0. the function will shrink away to nothing. There are a few other ways this can behave if you have x's again over other x's so that they're kind of fighting, but no number can keep up with a power of x that can just grow infinitely large. So whenever that happens, your limit will be 0, and you'll have a horizontal asymptote at 0.